So hi, I'm Nissim Kanekar. It's a pleasure to be here in Taiwan for the first time on the occasion of the Delta Award, and it's a great pleasure to be visiting National Central University and talking with the scientists over here about things that we are interested in. I am basically I work on a number of areas. I'm basically a radio astronomer, and my training was in galaxy formation and evolution, both theory and observations. These days I'm more of an observer. So I do work on things like I use the H1 21 centimeter line to study how gas in galaxies evolves with redshift. I also use telescopes like ALMA and the Giant Meter Wave Radio Telescope to probe gas in galaxies, again, the evolution with redshift. And I do, the subject of one of my talks on this visit is going to be fundamental constant evolution, where I use, again, spectroscopy, astronomical spectroscopy, to probe changes in the fundamental constants of physics with cosmological time. And the idea being that you expect that we have no good reason to know why these fundamental constants, quantities like the fine structure constant, the ratios of particle masses, should be fixed. And so these are basically a test of the assumptions. Such tests are tests of the assumptions of the standard model of particle physics. But you also expect in higher dimensional theories that try to unify the standard model in gravity and general relativity that these quantities will change with time. And so what we're trying to do is to probe their evolution on timescales of billions of years. And we've come up with a couple of interesting probes of the evolution using what are called hydroxyl lines, which is going to be one of the focuses of my talk over here at National Central University. I also do work on the interstellar medium in galaxies, mostly again using studies in neutral hydrogen, atomic hydrogen in the Milky Way, and also external galaxies. And I'm also really excited about trying to find pulsars at around the galactic center of the Milky Way, largely to probe general relativity in the strong field regime. This has never been possible so far. And we've been trying to do this now over the last few years with big telescopes like the Green Bank telescope and the Very Large Array in the United States. And the idea is that if you can actually find a pulsar going around the black hole in the center of our galaxy, it'll basically be a situation of a clock in a very strong gravitational field. And we have good predictions from general relativity as to how such a clock should behave, how the time in such a clock should behave. And so we can actually compare the measured period of the pulsar and its change with as the pulsar moves around the black hole with predictions from general relativity and basically test relativity in the strong field regime. And of course, that's an exciting thing because that's exactly, the strong field regime is exactly where we expect deviations from general relativity to happen, which are the kind of places where you'd hope to see extensions of relativity, which we don't know very much about today. So I think I'll stop over here right now. Thank you.